Okay.
So I think
The only thing that's an issue here with your bijection on the primes is if there was only finitely many primes, we might have a problem. So we need to be able to show that there are infinitely many primes.
Oh yeah. What am I thinking? People have proved that.
What were you thinking? I don't know. But
So
let's see.
I can prove this.
You can prove it. You can prove that there's infinitely many primes.
Yeah.
Okay, sweet.
So, I'm gonna use proof by contradiction.
Okay.
So I'm gonna say that there's only finitely many primes.
All right.
2, 3, 5, up to some prime p.
Okay, and that's the last one.
Yep.
Yeah.
All right.
And then I'm going to multiply all these numbers together
All right.
and add 1.
Okay.
Now this number is not divisible by 2, not divisible by 3. It's 1 more than a multiple of 3.
Yeah.
5, 7,
and our prime
up to p.
So this.
Okay. And so how did you make this number again?
So I multiplied all of these numbers together
Uh-huh.
and added 1.
Okay, cool.
So it's 1 more than any of these primes that we have.
So that and
It's not one more than any of the
Or
primes.
it's 1 more than a multiple of.
Right. When you divide this number by one of those primes, you get a remainder of 1.
so
That means either that this number itself is a prime,
Okay.
or it's a multiple of 2 primes that we don't have yet.
Okay.
yeah. So that either way, there's a new prime.
Yeah, we have to be just slightly more careful than that, but you're absolutely on the right track. Either the number is prime, or it's not that it would have 2 prime factors exactly. It would have some amount of prime.
so
it would have some primes.
It could have a prime that we don't have yet.
Yeah. Yeah, well, all the primes it has would be ones you don't have yet. But it just might be more than 2. It might be it might be a product of like 25 primes.
Yeah, we don't know.
But you don't know. But you do know that you don't have any of them because the ones you have don't divide into it.
So you can just keep doing this, and there's infinitely many.
There's infinitely many primes, and that means that
The
you've
bijection
made
is
a
true.
nice little bijection.
Yeah.
Well, actually, there's one more problem. Actually, now that I think about it, how do we know that the prime there's not more? Like, remember we talked about the real numbers have more numbers than the integers? They have a higher infinity. What if the prime numbers had a higher infinity than the positive integers?
Well, but the positive integers contain the prime numbers.
Ah, okay. So we don't have to worry about that.
Yeah.
We don't have to worry about that. So we've shown that they're infinite, and we've shown one lives inside of the other one.
Yeah.
And you've shown you can number them 1, 2, 3, 4, 5.
Yeah.
So good. All right. Nice work, guys.